winter dune regions. And although the materials are very different, this is actually very similar to some of the regions that we have here on Earth.
I am proud to announce that our next New Frontiers mission, Dragonfly, will explore Saturn's largest moon, Titan. Dragonfly will be the first drone lander with the capability to fly over 100 miles through Titan's thick atmosphere. Titan is unlike any other place in our solar system and the most comparable to early Earth. The instruments on board will help us investigate organic chemistry, evaluate habitability, and search for chemical signatures of past or even present life. This revolutionary mission would have been unthinkable just a few short years ago. A great nation does great things. We will launch Dragonfly to explore the frontiers of human knowledge for the benefit of all humanity.
The Huygens probe was provided by the European Space Agency, and it was a really tremendous mission. It was delivered by the Cassini spacecraft, and Huygens was the first probe to descend and land on Titan. And we're actually going to land Dragonfly near that location. And what Huygens did was tell us what the atmosphere is like, what kind of properties and conditions we can expect, and even to a limited extent what the surface was like. We would not be able to do the Dragonfly mission if Huygens had not provided the data that it provided.
Organic material in the sand dunes themselves and the sand particles.
In addition to that organic haze that's snowing down, Titan has what we call a methane cycle. You know, Earth has a hydrologic cycle where clouds form with water vapor and they eventually condense and it rains. Titan has something very similar to that, except instead of liquid water, it's liquid methane. Sort of like the liquefied natural gas that's in your propane tank for your barbecue grill. And this actually forms clouds in Titan's atmosphere, and it also comes together in storms, rainstorms, that then carve the surface and create lakes and rivers and canyons. And even though it's very cold on Titan, it has a lot of similarities to Earth in that respect. One of the great things about Dragonfly is with the cameras that it has looking forward and downward, as Dragonfly is flying over the surface, it's going to be taking pictures and sending those back to Earth. So we will actually get the experience as if we were riding along with Dragonfly, looking down at this alien yet very familiar kind of surface that has these rivers and mountains. And I think that's going to be a tremendous experience for the public, and I think everybody's really going to enjoy it.
It's unilluminated by the sun, the same way we have here on Earth, except that Titan's year is...
The ultimate goal is to get to Selk crater, which is a really large crater on Titan. It's about 50 miles across, and we want to get there because we think that at Selk crater, the three ingredients you need for life were mixed together, and that mixing is very important because when that impactor came in, it created a lot of debris and mixed them all together. So we want to get Dragonfly to that crater so we have a chance to directly investigate what happens when you mix those three things together. Because the great thing about Titan is it's very similar chemically to Earth before life evolved. And we can't go back in time on Earth and learn the lessons about the chemistry that eventually led to life. But we can go to Titan and we can pursue those questions and look at that chemistry and get a glimpse into what those conditions were like that eventually led to life on Earth.